we continue looking at basics of electricity, and this PDF document is presented by Siemens. Current. Electricity is the flow of free electrons in a conductor from one atom to the next in the same general direction. Now remember, we said before that you have electrons that are called free electrons that keep jumping from one atom to the next, but in no general direction. Now you can have them move in a general direction by connecting the conductor to a source, such as a battery or a generator. Now this flow of electricity, this flow of electrons is referred to as a current and is designated by the symbol I. Now when a river is flowing, you talk about the water current. So when electrons are flowing, you talk about the electron current. The symbol is I, uppercase I. At first, long time ago, when this topic was being studied and written about, since C starts current, it was considered to use C. But the thing is, C was already used to represent charge and coulombs. So they use I to represent intensity of current. Electrons move through a conductor at different rates, and electric current has different values. Current is determined by the number of electrons that pass through a conductor or through a cross section of a conductor in 1 second. So basically you measure current by considering how many electrons are passing a certain point on the conductor in 1 second. We must remember that atoms are very small. It takes about this number of atoms to fill 1 cubic centimeter of a conductor. So this number is 1 with how many zeros? 3, 6, 9, 12, 15, 18, 21, 22, 23, 24 zeros. Now this is a very, very large number. You can consider it as 1 million billion atoms to fill 1 cubic centimeter of a copper conductor. This number can be simplified using a mathematical exponents. Instead of writing 24 zeros after the number 1, we write 1 and the 24 as superscript. So it's, or we write 10 and then 24 as superscript. So it's 10 to the power of 24. A very large number. Trying to measure even small values of current would result in unimaginably large numbers. For this reason, a current is measured in amperes, which is abbreviated amps. So the amps is a short way of writing it. The letter A is the symbol for amps. So A represent amperes, and it's named after Andre Ampere. A current of 1 amp means in 1 second about 6.24 by 10 to the 18 electrons move through a cross section of a conductor, a very large number of electrons. These numbers are given for information only, and you do not need to be concerned with them. It is important, however, that the concept of current flow be understood. It should have been understood here. So you have a cross section of a conductor, and you have these electrons here. The plus would be protons, those are the center of the electron in the nucleus. The general flow of electrons is shown by this arrow. Now, unit of measurement. The following chart reflects special prefixes that are used when dealing with very large, very small, or very large units of current. So you have the kiloampere, that's 1000 ampere. The milliampere is 1,000th of an ampere, and the microampere is 1 millionth of an ampere, 1 over 1 million ampere. Direction of current flow. Some authorities distinguish between electron flow and current flow. Conventional current flow theories ignores the flow of electrons and states that current flows from positive to negative. So you see, conventionally, in general terms, you talk about current flowing from positive to negative, even though the electrons flow from negative to positive. The negative side repel them and they move away. The positive side attract them and they move towards the positive. So electrons actually flow from negative to positive. But by convention, we say the current flows from positive to negative. To avoid confusion, this book will use the electron flow concept. We state that electrons flow from negative to positive. Right? This is electron flow that you're talking about here. This is conventional current flow. On the left you have electron flow, negative to positive. On the right you have conventional current flow, positive to negative. Voltage. What we will do is talk about voltage in a separate video.